All right, so we are looking at our one-step equations. This is meant to be a shorter version of the notes because a lot more emphasis is going to be placed on in class. But again, it's something to go back to make reference to all those types of good things. So the idea behind equations, the whole idea is to find out what does that variable equal to make it a true statement. Does it equal 2? Does it equal 6? So what does B equal in order to happen? So part of it is we could do mental math. We absolutely could to try to figure out what number when we add 9 equals a negative 15. The issue though is as the numbers become larger, as the more negatives appear, decimals, fractions, we need a technique. So it's all about your inverse operation, so doing the opposite. So to solve an addition equation, we are going to subtract. So the opposite of adding a 9 is to subtract a 9. So when we do this, 9 minus 9 is 0. So all we've got is the letter B all by itself. And that's the goal when you solve an equation. Let's get the letter all by itself. So negative 15 minus 9, now we can see we have the same signs. So we're going to add and keep the sign. And it is an answer of negative 24. Let's look at the next style here. All right, a subtraction equation. So again, we're going to do the opposite of what we've got. So in this particular case, sorry, I'm trying to get rid of that highlighted portion that's there. All right. I guess it's just going to stay there. So in this particular case is we are subtracting an 8. Now notice here the variable is on the right-hand side. We say right-hand side because the equal sign is what separates the two sides. We've got the left side and we've got the right side. So the variable's on the right-hand side, so we're going to start there. So the opposite of subtracting 8 is to add 8 to both sides. All right, and so when we do that, we do negative 12 plus 8. Sorry about that. But now we can see we get an answer of negative 4. And negative 4 equals C. So in that case, it works. So let's use our substitution to check. And we had that up here as well. So we said the answer is negative 24. If this was our original, what we're asking for is if we say B is negative 24, is negative 24 plus 9, does that equal negative 15? And it does. So we have a true statement. So check, it is good. Let's see here. Here we had negative 12 equals, all right, and then C minus 8. And so we're going to plug in negative 4. So negative 12 equals negative 4 minus 8. Is negative 4 minus 8, does that equal negative 12? Yes, that is a true statement. So this is the wonderful thing about solving equations is as long as we check, we know whether we got the correct answer or not. So this is a perfect problem as to why we just don't rely on mental math there. It's a little too much. So here we are adding it on, so we're going to subtract it away. And we are going to do to both sides. So what we say is we are going to subtract 8 and 35/100ths from both sides. Now why subtracting? Well, here's the whole thing is what is 8 and 35/100ths minus 8 and 35/100ths? 0, nothing, it's gone. So all we have is the t all by itself. If we added that together, we would not get 0, we would not get the t by itself. So now we can see we have the same signs, so we are going to add and keep the sign. So a 0, carry the 1, a 9, an 18, bring our decimal straight down, keep our sign, it is a negative. So we can check it. Is 8 and 35/100ths plus a negative 18 and 9/10ths, does that equal negative 10 and 55/100ths? Well, for this particular check step, we're going to do a little bit more than just say, yeah, because of the mental math here. So we have different signs, so I'm going to subtract. All right, 8 and 35/100ths. So little 0, little borrowing. All right, there's the 5, a 0, and a 1. And keep the sign of the larger number. Did it match up? It most certainly did. So we can say check. All right, it is good. All right, so let's skip a little bit here. Let's get to the multiplying and dividing. Just like before, we do the opposite. So the opposite of multiplying by a negative 3 is to divide by a negative 3. Now notice we're using our fraction bars for division. Notice it's not about changing the sign, because what is negative 3 divided by negative 3? It's 1, and that's what we want. We want 1z. Now again, we don't put the 1 in there, we just put the z itself. And now we can see negative 9 divided by negative 3 is 3. So if we check, all right, and we plug it in, is negative 3 times 3, does that equal negative 9? It certainly does. Let's go to the next one here. Here we are dividing by 4, so the opposite of dividing is to multiply. So we're going to multiply. We show that by using parentheses off to the side. All right. Really what's going on here is 4 over 1, so you can see your cross division knocks each other out. This is why we simply do the opposite operations, is because we know we're going to get just a 1 that's there, just a plain old y. So we don't have to show that. We can if we like, but we are showing it to both sides. If we check, is negative 8 divided by 4, does that equal negative 2? It certainly does, so we know that we are good. Let's try, we'll make these last two. So here we are dividing by a negative 3. So again, we're starting this side with the variable. We are multiplying. So to undo multiplication, we are dividing. So I would divide both sides by negative 3. And again, you can see that negative 3 divided by negative 3 is 1. It's just an m. 21 divided by negative 3, negative 7. All right, and then we can check, is negative 3 times negative 7, does that equal 21? It certainly does. And let's just do the one more. All right, the opposite of divide. Now, we are dividing by a 10, but we are dividing by a negative 10 here. Now, if you're like, wait a second, I don't see that as a negative. Let's think about it. What is a negative times a negative? It is a positive, and that's the goal, is to get an n all by itself and for it to be positive. So we're going to multiply this side by negative 10, and so negative 780. And again, if we check it, negative 780 divided by 10, we got the negative sign out in front, double negative. So that's just going to give us a 78, and that is what we had over there, so that would be correct. Let's come down here. I forgot about these guys here. Let's take care of this. Write a multiplication equation that has a solution of 12. So I need it to have a solution of 12. All right. I need a variable with it, and I'm going to have some number here. Now, solution of 12. No. That's not a solution of 12 out in front of it there. This is my final answer that's here. So what I'm going to do is I'm actually going to adjust this a little bit. I need to get an answer of 12. I need some number, and because it's a multiplication equation, I need some number up against x to get an answer that equals something, and I need an answer of 12. Well, the whole idea is this. When you do a multiplication equation, what do you do to solve it? Well, to undo it, we actually end up using what operation? We use division. So what I really need are two numbers that divide to give me 12. All right, so how about like 24 and 2? All right, so I could say 2x equals 24. All right, and let's check to see if it works. If I got 2x equals 24, I'm going to divide both sides by 2. 24 divided by 2, yeah, 12. So we're good. All right. The last guy here is, again, we want a solution of 12. So I'm going to say I need an answer of 12, but I need a division equation. So I need something, all right, some letter divided by something to give me some sort of number, but I need the answer to be 12. So remember, the idea is to solve a division equation, you use what? We use multiplication. So what are two numbers that multiply together to give me 12? And we could say, how about 3 and 4? So x divided by 3, set that equal to 4. To prove it, we're going to multiply both sides by 3. So here we have x equals and then 12, so it worked. So my answer there, my answer is x divided by 3 equals 4. All right. Whereas up here, my answer was 2x equals 24. And again, we want the solution to be 12. So when we solved it, I got 12. When I solved it, I got 12.